Okay, I think we're finally ready to start. Apologies for that. So I'm Magnus Feuer. I'm head of technology at MBition, which is, as presented, a division inside Mercedes that focus on software development. Currently, we're focusing mostly on the infotainment system, and as such, I'm responsible for this infotainment system's long-term strategic roadmap. Where are we technically? Where do we need to be? Which capabilities do we need in the future, etc. So today I'm going to talk about API first principles and what we're doing internally with that and how that impacts our emerging engagement with free and open source software. And this presentation, it's about 20 to 25 minutes long, is divided into two parts. First of all, we're going to look inward, and I'm going to show you a little bit about what the thinking is inside Mercedes-Benz right now and what we are changing in our mentality when it comes to software development across multiple ECUs inside the vehicle. After that, we're going to look outward in part two and see how does this change when it comes to principles, manifestos, etc., impact our engagement with the outside world through the lens of open source. So the first one, the problem statement is quite simple. We have hundreds of ECUs, and this is for industry in general. How do we coordinate software development across these ECUs? How do we manage this across all the vehicle network, sensors, ECUs, actuators, etc., without tripping each other up? How do we enable the individual projects to work on their own thing and at the same time being able to integrate continuously? How do we do variance management across multiple ECUs, different car lines, different models, different years, different markets, different configurations? This is an exponential growth that in different combinations of software that we need to solve. And finally, how do we combine the real-time world of AUTOSAR, and I use that as a label more than an actual thing, together with the higher level POSIX, which is Linux, obviously, that's why we're here, QNX, and a few other operating systems as well. How do we combine hypervisors with the real-time, hard actuating and sensing functionality of the vehicle itself? And how do we do that into a single solution? See if this works. It does not. So internally, we have something called MBOS, so Mercedes-Benz Operating System. It is our foundation for all the software we're doing inside Mercedes. Our infotainment system is the first one out of the gate on this that uses this. And I'm a part of the architecture group for MBOS across Mercedes-Benz. And we just internally are creating a manifesto that contains the core strategy for how we're going to do software across all of Mercedes-Benz and MBition and all the other subsidiaries. This one is still internal, it's still in development, but what I can talk about are a number of core principles that we can extract from that manifesto that impacts our open source engagement. So first of all, kind of basic, if you've done software outside automotive, etc., and it kind of starts to become a truism inside automotive as well. We want to abstract software from hardware, and by extension, we want to abstract software from car lines and vehicle, so car lines, production, etc., different variants there. Car lines have their own cadence. They have a start, they have a design, they have prototyping, manufacturing, and end of life, and everything else. Software has its own cadence, and we need to separate those so that software is designed, developed, tested, released independently of the car lines and then integrated with them. So we need this abstraction layer. If you buy into the first principle, the second principle will be that we need to distinguish between the API, the defined behavior of a feature, which can be anything, from its implementation, two different things. There's actually a third thing, which is testing, which I'll get back to as well. And these are version managed separately, they are released separately, they may be developed by different teams, etc. I'll get back to that as well. If you buy into the separation of API from implementation, you pretty soon come into the point where you need to rapidly develop your code. And that turns into, from our point of view, that we cannot have a big design up front, where we do 10,000 requirements, which I've seen, and then we do a huge design, and we start implementing, and at a late stage we go, oh, we didn't think about this edge case. What about this? We do late stage redesigns, which usually leads to problem. So we need to be able to incrementally code a bit, document that, update the design, code a little bit more around that, and do an incremental agile development Nothing special there as well, but for the automotive industry, it can be hard to integrate in the day-to-day process that we have. And if you buy into the third principle, then you realize you need to test this fast and quickly. Test today can take a long time. You need specific hardware, etc. But what we need is to center the development around test-driven development. It's that simple. A machine-executable definition of done, enabling each developer to know, am I, at this point in time, done with my code? Am I feature complete? Does it pass test? Can I check this thing with confidence before I have hardware, before I have a vehicle, before I have a test rig? So we're going to talk a bit about that as well. So in the next slides, I'm going to go through these 4 principles and kind of dive into them a little bit. So first of all, use abstraction to decouple platform from hardware. We have an abstraction layer. Let's see if the laser works. Probably not. Yeah, it did. Good. So we have, what we're doing is that we're dividing it into 2 layers, which is command and control at the higher end, and then we have the data plane at the bottom end here. And what we want to do is to standardize the API, go API first for the high-level commands that flow from command and control into the real-time part of the vehicle itself. And from there, we can do low-level control of actuators. We can sense, and we produce raw sensor data with high frequency, but low value. If you have wheel speed at kilometer powers or ticks and a Hall effect sensor, it really doesn't say much about where you are, how far you can go, etc. So what we do here is that in the integration layer, where we merge the car line specific hardware with the general abstraction, we do sensor fusion and collapse and increase the value and refine the sensor data into low frequency, high value data, which can then be acted on by the high level ECUs and the car computer, etc., for the MBOS network layer. And then the command loop goes down again and up and around we go. The important bit here is that everything is standardized around the API and that these bits can be variance managed by car line, by models that can be updated as long as they implement the same API, then we're good. And again, that means that the APIs are managed completely separately from the implementation, and when the system architecture group gets together with representatives from all these ECUs, this is what they negotiate around, not the implementation themselves, not requirements. And that single unified API specification defines the behavior, the internal behavior of the vehicle. And this also finally gives us a separation between the POSIX layer, the command and control, which we run Linux. It's not fault tolerant or safety critical usually. It's more traditional, call it development, with the model driven, lower level, hard real time, functional safety, out of our world of things where you actually actuate. And the API again is the delineation between these two. So if we look again at the APIs from separating the APIs from implementation, there are actually 3 things, 4 if you want to pinpoint it, that's at play here. And we start, since we want to do a machine executable definition of done, we have a test script. And this can be anything. It can be a robot, I'm going to get back to this as well, but we need a way for us to test whatever code is done, regardless of which stage the code and the hardware is in. And often we start the development, software development, way before we have any kind of engineering samples, test rigs, not to mention prototype vehicles. We need to figure out how to test, in this case, the FM tuner. And as a point of clarification, I'm using the FM tuner as a very generic example. Everybody knows what the issues are with it, with artwork and background scanning and stuff like that. It's just a convenient placeholder. This could be anything. So once we have a machine executable definition of done, we can now automatically test not the implementation, but an API that wraps the implementation itself. From this, we can auto-generate network binding and language bindings, much like FrankIDL does and gRPC and everything else, nothing magic there. And the key here is that once the architecture team delivers the FM tuner, the test spec, they also deliver the mock code, which is a dummied up code. It implements the API, it has the networks binding, it doesn't do anything useful, but you can test it. It will fail, but that's fine. you now know that I have a failing test case here that I can execute again and again, and I can gradually replace that mock-up code delivered by the architects with my real implementation as I go ahead, and start replacing it with production code that I then run in the simulated environment on my laptop or in the cloud. I move to emulated environment, and finally I move to hardware loop testing as well. And this requires us to have a clear life cycle for APIs, for the implementation, and also for test. If any of these changes, these three, you need to retest the entire system. And by extension, also if you change the build system itself, new version of Yocto or whatever you use, you need to retest as well, because there are new compilers, the new libraries at play. Once we have that, we can start evolving the specification with the implementation in lockstep. Code a bit, figure things out, document that, move forward. We had a long conversation inside MBition about ASPICE. Is this ASPICE compliant? And the answer came out yes. As long as you do the full circle and don't skip on documentation, release management, and requirements management, and you actually develop all the cycles in lockstep, you can iterate as fast as you want. You can do this once a day. You need the right tooling, you need the right processes, you need the right mentality, but there's nothing in ASPICE that stops you from doing this as well. And again, all these three things are managed separately, and they are designed in separate teams, and they are agreed upon in separate teams as well, APIs, code, and tests. And all this pushes back against a big design up front. I don't know how many times I've seen the perfect requirement spec, the perfect design, and everything falls apart at the very, very end when you start integration tests with other ECUs in a specific variant of the vehicle. Oh, what about if you have some rear seat entertainment or this model installed? And you go, this doesn't work. We now need to do a late stage redesign that impacts implementation. And that's when you start to see risk across for startup production, etc. So we want to push back against this by step, collectively reaching the right design and the right implementation. And then we move on to tests. Just again, ASPICE terminology here, nothing special. I develop a component, which could be the FM tuner. I need a way to exercise the API and have a machine-executable definition of done. Once the component is done, I want to roll this into a bigger software element that's tested as one coherent unit. This could be a streaming media service or something like that. It doesn't really matter. And finally, we integrate the software element into a subsystem which is a bootable image in the ASPICE terminology. It could be a virtual machine, it could be a standalone unit, it can be an ECU, whatever, that then is integrated into a system, which is the whole car. So again, single source is definition of truth. Sorry, we have a single source of truth that defines done. We need to separate validation, which is, have I built the right thing? Have I created a system that solves the right problem? Do I fulfill the requirements? Do all the functional requirements in place? And from verification, which is non-functional requirements, what's the memory footprint? What's the speed? What's the booting time? And down to thermals and things like that as well. Today, validation often happens very, very late during integration tests. You can find basic issues, which is risk. I want to be able to move validation up to component way before we have hardware available to find out, does this FM tuner do the right thing? Does the software element do the right thing? And does the subsystem in a virtual environment do the right thing? Yes, okay, now when we have hardware, we can start verifying it. So what do we want to achieve? Well, obviously faster time to market, which our colleagues from Panasonic pointed out. And we believe we can do that. But more importantly, we want to decrease risk by increasing confidence. In many, many projects across the industry, we have issues with surprises popping up late, unknown unknowns that surprise us way, way, way too late in the project. That induces risk and everything becomes very, very stressful. We want to be able to as early as possible, by validating from day one, testing from day one, give high confidence estimates of how long is this going to take, when is it done? Because at the end of the day, if you ask a car line project lead what they need from us, they need a due date when it's done. And everything is centered around that, and we need to help them as much as possible to get there. We want to move the conversation from either high-level features and requirements, which are definitely needed but they play an outsized role today, into a design and engineering discussion around call flows between ECUs, inside ECUs, APIs, how do they interact, can we cover all the corner cases with this current API, and then we can move into the implementation of that. The system architecture group on a company level needs to agree on all these. They sit down, they put all the APIs on the table, and they whiteboard their way through this, sequence diagrams, whatever you want, until we go, yes, this will work. Let's build a first iteration that we can have a starting point to quickly iterate and evolve implementation with specification. And being an OEM, yes, we want to mitigate vendor lock-in. We want to be able to replace major technology blocks without having to tear up the entire system design. And if you have a well-defined API management in place, that enables you to do that. And as I pointed out, mitigate variance risk. If the API is what we negotiate around, we can have multiple implementations for different car lines, different markets, different configurations, different years, implementing the same API again and again. That allows us to limit the impact of market-specific variance and the weirdness of those things, because they're always special solutions into the whole system. So part two, how does all this, which was inward-looking, how do we change our way we develop code inside Mercedes-Benz? How does this impact our engagement with open source? Well, first of all, I think we need, and this has been mentioned earlier as well, we need to start creating a set of open vehicle API standards. These, I'm going to get back to which level I'm talking to. We're doing this a little in on the Covesa side, but there's no code there. It's only specification and some tooling as well. I think we need to extend this into the code side of things, and I'm going to get to that as well with a proposal. We should focus on non-differentiating services, things that do not sell a car. You don't sell more cars because you have a really good FM tuner or Bluetooth stack or software over there update procedure. It's supposed to be there. It doesn't add any value. However, if it's not there, it's going to remove value from the vehicle. If there's no FM tuner, you can't update the vehicle, people are going to get angry. So let's focus on these things that we implement again and again and again. And I know that the tier ones are tired of it. I know that we are tired of it. I know that the tier twos have done this again and again. Let's establish something that we can kind of at least use as a baseline. I also want to erase the, there we go, still works, the boundary between the cloud and the vehicle. If you have strong APIs and a good API management, the only difference between executing onboard and offboard are three things: security, safety, and data link robustness, because mobile data links come and go. You can run speech onboard for natural language understanding and TTS and everything else and ASR, and you can run it offboard, or you can run a hybrid. It's the same API. It's the same thing that needs to get solved. It's a deployment question at this point. And if you have a strong API definition and you have standardized vehicle services, you're now free to deploy where you want to deploy, even across different ECUs. And finally, use open standards as a foundation for industry collaboration. According to attorneys, et cetera, I've spoken to, the only safe place, at least in Europe, legal space, where we can collaborate between OEMs and tier ones without running into major anti-competition laws, antitrust laws, are in public organizations such as the Linux Foundation, or Automotive grade Linux in this case. And we should use that as a way of coming together to solve the non-differentiating service problems that cost a lot of money but do not really add any value. And finally, very important, if you have open APIs, open source projects tend to come out of that. People spontaneously start to implement them. Conversely, if you have closed APIs, you usually get closed source implementations that cost money, that's not easily accessible, that you need to pay a tier one, or sorry, a vendor for, a stakeholder for, and that's that. You're kind of locked into that as well. So we see a number of things that are needed. First of all, we really, really need to be able to, each developer, software developer, a guy who's just writing code in C++ or JavaScript, whatever, to know, am I done today? Tomorrow the requirements may change, the design may change, the test script may change, the API may change, and then I'm not done, but today I'm done because the test script passes. We need that. And in order to do that, I think we need a new set of tools that implements a single integration test strategy regardless of where you are in the stack, that you can feed simulated sensor network traffic into, you can exercise the API, and that you can start to set up a simulated vehicle that the code under test, it doesn't know that it's being simulated or it runs in a simulated environment, but you have this entire mock-up infrastructure in place that allows you to automate all aspects of the low-level component test, but also for the integration tests. And that allows us to go from laptop to cloud to software in loop emulated to hardware in loop testing seamlessly. And finally, innovation. Yes, that's what we need. If we have a well-known open API ecosystems with reference implementation and open source, that invites to new thinking, new innovation, and more importantly, it provides a clear pathway for the OEMs and tier ones when a startup comes, and we've all run incubators and hosting startups, etc. But the big question is, how do we get this to production? It's such a huge hurdle with certification, integration, and everything else to get it out there, the new technology itself. Having a clear API management and open APIs, for example, for payment, location-based services, messaging, biometrics, whatever, that integrates into the lower level of the vehicle, then with an open source reference implementation, the path is clear. And innovator can come, a startup can come and approach an OEM or a tier one and say, I have this awesome thing. The tier one goes and say, oh, that's awesome. Here's the APIs to all the things that you need to use, navigation, ADAS, comfort, etc. Integrate your technology on top of this using these APIs in a production vehicle that's already on the road, so we can have a look at what will this look like in production. That's where we want to be. No more PC in the trunks, no more screens screwed onto the dashboard. We need to get an experience in order to sell this internally to look just as it would in a production vehicle. And open source provides a higher starting point to do that. If there's an implementation available, the innovator, in this case startup, can use that as a starting point, look at it, and from there move on and build on top of it instead of starting from scratch. So where are we going? I think this is the last slide. Well, we have a clear open source mandate from the Mercedes C-suite, Mercedes-Benz C-suite, sorry, there's a spelling error here. And we are building up our internal FOSS organization, both in MBition, which I'm leading, and in the wider Mercedes, and we work, Mercedes-Benz, sorry. We work very, very closely together on that. As we are doing that, we plan, our intent is to incrementally engage with open source projects. We have all the legal bits in places, we have the procedures and policies and everything needed, but now we need to actually figure out how does our API first strategy and principles translate into concrete open source project per se. What we've agreed on is that we will focus on projects that enable automotive software. We will not do awesome leading edge features, something like that. We want to be able to put things in place that enable innovation, the next generation software, faster and more with higher confidence. We need development and test tools. There's a lot of awesome things out there, but we need more, especially on the test side. We want to standardize the APIs and also have the APIs implemented as these foundational components. And I see Linux Foundation playing a role here. This is the last slide. So what's next? Well, this is not a call to action because we need to figure out more. It's a call to conversation. We need to have a chat with people like this across the industry in this open space where we can actually talk about it to some degree to find more engagement points. How can we, what are the opportunities here? And we want to explore these new projects together with AGL and other organizations as well. And the best way to start that would be to run a pilot between OEMs, well, and tier ones, or actually any stakeholder in the industry. I'm really not set on OEMs. And what we can use as a starting point, just to test out the process more than anything else, could be Comfort API. And there's already some standardization going on there. It's very early, it's alpha release, but we have something. And can we build business logic around that in the comfort domain, inside the infotainment system in this case, and as a proof of concept, we could bring your own device application that allows you to set seat massage, ambient lighting, HVAC, and all the other things in the cabin as well, just to try things out in a production vehicle. If we can do the same solution in 2 production vehicles, it's even better because different OEMs, interoperability, that's what we want. So again, I'm not saying we're going to do this. I'm not saying, yes, Mercedes-Benz is going to be in the forefront and we're going to drive all this, but Mercedes, we want to have a conversation to jointly explore what can we do next. And that's that. I hope I didn't run over too much time.
No,
Dan?
perfect.
Okay. Thank you so much.